Hi, welcome to DIY Fab Shop. This is literally the first video for this channel. I'll share a little bit more about my plans for the channel at the end of the video. For now, I'm excited to kind of jump right into this first project, which is to fabricate a better shop stool. So let's start by looking at a typical big box version, right? So I'm sure many of you kind of suffered through these with these kind of small, crappy casters. They generally have this small footprint that makes them kind of unstable. Especially if you're zipping around with the seat up a little bit higher. And if you think about it, there's a lot of pressure on the manufacturer and the sales channel to keep these a small footprint and make it a not great product. You know, the sales channel doesn't want to have it taking up a lot of shelf space at this price point. They don't want to be shipping around a lot of air, and they're probably convinced themselves that the consumer doesn't want to spend any time assembling it. So by the fact that you're here, I'm sure you're the type that would put in the time to build a better shop stool. So thanks to a time machine, we're going to take a look at what we're going to build today. All right, not a time machine, just video editing. But here, let's take a sneak peek. So the design has nice large 4-inch casters, a smooth urethane rolling surface, and a ball bearing design. It's really the heart of the design is these really nice casters. Instead of 4, there's 5, providing a nice big footprint to provide stability. And there's an air cylinder for adjusting the seat height. So the video today is going to go over fabricating this and putting it all together. On my website, you can get access to the CAD models, drawings, a link to all the purchase components, everything you really need so that you can fabricate this exact stool if you wanted to. You know, I tried to keep it a fairly simple design in that you don't need a CNC plasma cutter to cut any of the metal parts out. All the raw materials can actually be purchased at a well-stocked hardware store or a Menards, Farm and Fleet, Tractor Supply, stores like that. You know, one thing that would be beneficial is a welding fixture table. Probably not completely necessary, but it does make it a little bit easier to put everything together. This version I got from Northern Tool. Harbor Freight recently came out with a version. It's really entry level. For about $200, you can get a nice sized little table and the fixtures and clamps. So let's jump into the CAD model, and we're going to start fabricating after that. So the software I'm using is called Onshape. If you're not familiar with it, you should check them out at onshape.com. It's a full-fledged commercial 3D modeling software, and what's great about it, it's pretty easy to learn how to use, and they have a free version for non-commercial use, perfect for DIYers. So I laid out this general shape to accommodate the 5 casters. I have a nice big footprint here, about 23 inches across the corners. Needed someplace to put the cylinder, so I created this little pentagon cylinder pocket. That's going to hold the gas cylinder, and needed to put something to support that. So at the bottom, I have included a little support plate with a hole in it. You can see that here. And then I needed to tie the cylinder pocket to the base tube, so I added these angled support tubes. You can see it comes off at a 45-degree angle off the cylinder pocket and has a little notch or a little bird's beak where it hits the base tube. And then I needed some way to attach the casters, so I used this 3/16" steel plate. The real benefit here is that these plates support butt joint of the base tubes. Next, I'll show you the 3D printed fixtures I designed. It'll be the parts in orange. This one on the bottom holds the 1/8 inch flat stock in the right orientation to create that pentagon. It also spaces the cylinder pocket up off the fixture table at the right elevation for welding everything together. On the top of the cylinder pocket, I have another fixture that holds the flat stock in the pentagon shape and centers the angled support tubes on each side of that cylinder pocket.
I also created some 3D templates, things like this little part helps scribe the bird's beak. Certainly not required. Just makes it simple. If you have a CAD model 3D printer, why not, right? I also made one for the caster plates to help template those out as well. So let's transition to looking at the rest of the design. I'm going to hide these fixtures and show the casters. Beyond the casters, we have the cylinder goes in the cylinder pocket. Bracket goes on top of that. And the seat cushion on top of that. And I did add one kind of optional part. I added this little cosmetic cover 3D printed part for over the cylinder pocket. As a reminder, all this design documentation is available for free on my website, including the STL files for 3D printed parts. If you don't have a 3D printer and you're interested in getting a hold of the 3D prints, why don't you put a note in the comments? I would consider making them available for purchase if there's enough interest. All right, let's start cutting out some parts. For the angled support tubes, we'll start by cutting one end with a 45-degree angle, and the other will just have a straight 90-degree cut. With the angled support tubes cut to length, now I need to mark the bird's beak for cutting. I have a little template to describe that. All right, now we're going to cut our bird's beaks and clean up the parts. Okay, now we're going to cut the cylinder pocket sides to length and clean up the parts. All right, now we're going to cut the cylinder pocket bottom material to length, cut the hole with a hole saw, create the pentagon shape with cutoff wheel, and clean up the part. Okay, for the caster attachment plates, I'm going to use this 3D printed template to mark the profile and also the center point for the hole. We're going to cut these pieces to length on the bandsaw, drill the hole on the drill press, use a cutoff wheel to cut off the angles, clean up the part. let's use one of these fancy fixtures. So this is to create the cylinder pocket, the pentagon shape. There's a bottom fixture and a top fixture. At this stage, where we're tacking things together, this inner lip faces towards the pentagon. After we've welded it up, we're going to use the other side. But for now, this is the first step. We load our 1/8 inch by 1.5 inch wide by 9 inch long steel sides of our pentagon. We put those into the bottom, and then this is a little bit trickier because now we have to get this fixture on the top, and it takes a little bit of finagling. I can assure you it's a lot easier to do not on camera, but look at that, pretty easy. So now we snug it up and we can lay our tacks in here to create our pentagon shape. Voila, we have a pentagon. All right, so now with the cylinder pocket in a tacked into a pentagon shape, I need to put the bottom in the pocket that will support the cylinder. And in order to do that, I actually had to grind the outside a little bit just to kind of fit it to the pentagon. I didn't quite have it per print per se. And I'm gonna set that down in, I don't know, somewhere between 1/16 of an 1/8 of an inch, just so that I have a place for the weld, because I'm gonna come back and grind it flush so it fits in my fixture well and so that it's clean on the bottom. And I don't wanna take away all of the weld, so I'm gonna leave it just short of the end. See that? I'm just short of the end. All right, I think we can go ahead and weld it up. All right, let's clean it up. Cylinder pocket done and ready for the next step. All right, so next we are going to lay out the base tubes and the pentagon shape on the fixture table so we can tack it together. So I have already marked some points on the fixture table. I established a center. You can see it goes to the other side. And I have marked my far leftmost point at 12 1/8 inch and my far rightmost point at 12 1/8 inch.
And I have placed the first tube on center with that center line. And now I will add the other 4 tubes with the peak finding its point on that center. All right, let's lay out the rest of the tubes. All right, let's tack it up. Okay, so I have tacked the inside, top side, and outside of each of the joints. Now I'm going to take the base frame and flip it over and clamp the caster attachment plates over the joints. All right, now we're going to tack on the caster plates. All right, now we're going to flip it over and see how flat it is. Pretty good. Okay, now that we have the base all tacked together, we're going to add the cylinder pocket and our angled braces. And in order to do that, we're again going to use our fixtures. Last time we had the inner lips facing the pentagon. This time the inner lips face away from the pentagon. This side as well. The lip is away. And I have marked the center of the angled tube on the bird's beak end. And I have also marked center on the base tubes. I'll work my way around, add in the tubes. All right, now I go around and make sure all my lines are on center. So my angled tubes are going right to the center of the base. I'm gonna make sure everything I'm gonna wiggle the fixture a little bit and just make sure everything finds home and is aligned. And then I pull off my fixture, inspect the angled tubes, and how they hit the cylinder pocket, and everything looks great. Ready to tack it up. Here we go.
All right, time to clean up these welds.
All right, we got it all cleaned up, ready for paint. I was thinking I would just finger paint it with a rattle can, but you know what, it's turned out so nice, I think it deserves my very best paint booth and my very best sprayer. There's my paint booth. And this is my very best sprayer. Let's put these casters on. I got washers and lock nuts as well. If you haven't figured that out already, DIY Fab Shop is a Milwaukee house. My favorite tools. All right, chair cylinder and a little beauty cap. All right, next we are going to attach the bracket to the cushion. All right, we are going to attach the bracket to the cushion base. I have centered the bracket and marked some locations for some pilot holes for some leg screws. Go ahead and drill them. So I don't know if there's anything real critical about this step, but I guess I should say that you want to make sure you don't use too long of a screw or leg bolt, whatever you're going to use. If you use too long of a screw and find out the hard way the first time you sit down on the shop stool, that's on you. All right, let's put it on. There we go. All right, there you go. DIY shop stool. Metal you can buy at a local hardware store, Menards, Farm and Fleet, Tractor Supply, stores like that. Components you can buy online. Get out your welder, something to cut some steel with. Spend a couple afternoons, save yourself some money. So let's talk costs. So a big box store shop stool, probably a minimum of $40, probably more typically $50, $100, $150 for a premium brand. Even those $150 shop stools, from what I can tell, still have small casters, small footprint, not a great functioning shop stool. So there is an American-made version. There's a company that sells an American-made shop stool that has 5 large 4-inch casters, big footprint, beautiful powder-coated frames, nice embroidered seats. Depending on the features, they can cost as much as $600. That's a lot of money for a shop stool. I have $300 into this. So twice as much as the premium brand from a big box store, half as much as the Made in America one. If you can afford a $600 shop stool, you should buy the American made version. Support a great company. If you're like me and you have do-it-yourself in your DNA and you enjoy the journey as much as the destination, you should build a $300 shop stool and justify that you now save money that you can spend on tools. I've been doing that for 40 years and I see no reason to stop now. So like I mentioned, this is video number 1 for the channel. Be great if you'd go into the comments, tell me what you liked, tell me what you didn't, what would you design differently, how would you fabricate it differently. I appreciate you taking the time to do that. What's next for the channel? So while I love everything kind of DIY, my real passion is around amateur car racing. And I have been building, maintaining, and racing cars in the Champ Car Endurance series for about 10 years. Thus far, all of that has been done out of my garage. I love my space, but kind of outgrown it. So I'm super excited that out in the yard, coming online just now, is a brand new dedicated space. So I intend to include in the channel kind of building out that shop. Things like epoxying the floors, installing a boiler for the in-floor heat, installing a 2-post lift, organizing the shop, all those types of things. as far as race cars go, I currently race a 2002 Lexus IS300 with some really good friends. That car's already built, so videos around that will probably be more about maintenance, upkeep, those kinds of things. But I have another itch for something, car related, and I'm thinking about building a old muscle car. So in this case, not a restoration project, but a resto mod. So adding new technology to an old platform. Ideally, I'd love to get something to the point where I feel like I could compete in the Optima Ultimate Street Car Challenge. So I don't have a car picked out yet. I do have some ideas. Nothing too crazy, but I hope you'll subscribe. Join me on this journey because it's going to be great. Thanks for watching.